everyone. Let's play a game. Imagine you are building a 50-story skyscraper using matchstick, okay? Now and glue. Now that's exactly what writing a large test bench in your Verilog feels like. Fragile, messy, and sometimes ready to collapse with one wrong signals, okay? Just like your matchstick. But what if I told you like you are a smarter way or you can have a smarter way, one that makes your test bench reusable, scalable, and way easier to manage. So, welcome to the world of object oriented programming, which is there in System Verilog. So, hello everyone, I am Kittu Patel, and in this video, we are deep diving into why OOPS is a lifesaver for verification engineer. If you are new here, so don't forget to hit that subscribe button for more powerful Verilog content. So, let's start the video. And before that, if you want to learn something from me, so these are all my contact details. So you can directly connect with me on this number, and you can also send a mail regarding your whatever doubt you have on this mail ID. Okay. Now let's start the video. Now let's see what are the limitations of traditional Verilog. Alright, so let's address the elephant in the simulation lab. Plain old Verilog. So great for RTL, but when it's come to the verification, Verilog is like a procedural, meaning like it giving a chef only one recipe and telling them to cook 100 dishes. So you can end up with copying, pasting, and tweaking and slowly losing your sanity. Okay, so there is no encapsulation everything. So out in the open, like so kind of like your Google search history when your friend uses your laptop. So scaling your test benches. So forget it. It is like adding a second floor to a house made a Uno card. So in short, like your verification with traditional Verilog is painful, repetitive code and not built for the complexity we deal with today. So why we need OOPS in System Verilog? So here comes our hero, object-oriented programming. Okay, or OOPS you can say. So System Verilog introduced OOPS to solve exactly this problem. Think of it like a Lego. Instead of gluing everything together in one go, you are building a reusable block. Okay, so like instead of you can say gluing everything together in one go, you are building some reusable block. A brick for stimulus, or you can say a brick for monitor, scoreboard, and so on. So you can organize your test bench like a pro. Break it into the manageable units, reuse your code, and make your life so easier. So plus, if something break, you don't have to dig through 100 or 1,000 line. Okay. So and guess what? This also make debugging feel less like detective work and more like editing your own well organized notes. Okay. Now let's see what is class in System Verilog. So these are all the concept of OOPS. So you can learn classes and object in System Verilog, inheritance, polymorphism, and encapsulation, which was there in System Verilog. We will learn each thing in detail in our later video. We will also see how to build our reusable test benches, and then we will see what is the real world project examples. Okay, we will practice much more example also. Now let's see what is the class in System Verilog. So see, let's break down it. So what is a class in System Verilog? So imagine you are designing a car. So just imagine you are designing some car. Okay. Now every car has some common thing like its engine, its wheel, its steering. So these things are common in every car and it can do stuff like start, stop and honk. Okay. So in System Verilog, you define a class. You can say in System Verilog, you are defining a class where you can making a blueprint of car. Inside that class you can define their properties like command address, or you can say like the properties of your car, and you can also able to define your method. So every time you just want a car, so you can create an object based on that class. Okay, now let's go through the code. So see, here is a practical example, a packet class. So we have properties like command, you can say address and status, and constant like header size. Okay, so we have considered here four properties and we have considered here constructor. So we define a constructor using new keyword here you can see, and to initialize your value, just like setting default value in your Google Forms. Then we have methods like clean you can say, and issue request you can say, and then int current status. So these are the method. So method are those things who are defined as a task or function, and the properties inside the class are called class properties. Okay. Now how class work internally? Let me see. Okay. Now let me see how class works internally. So now here something cool. So these classes are dynamic. So that means you can create or destroy object while running your simulation. Okay. Now each object is accessed via handle. We will also see through example, but just for the being of theory, you can understand the we are accessing your class member through handle. So suppose here your class have named packet, so you can write the name of the class and you can make one handle. So here pk1 is our handle. Okay, so we have defined one handle. So what does it mean? So your each object is accessed via a handle. Think of it like giving someone the remote control to a smart device instead of the actual device. Okay. So and when you pass an object as an input or output, so you are passing the handle, not the entire object. So that save time, space, and avoid unnecessary duplication, you can say. So this is especially useful when you have to share some same packet data across multiple verification components like your driver and monitor. Okay. Now let's see a conclusion. So see, here the takes away from the system Verilog OOPS capability is that it helps you to write a cleaner, more modular and reusable code. Okay. And with classes and object, you can organize your verification logic, debug it faster, and even build test benches like pros at companies like Intel and Qualcomm. And if you are still writing all your tests in a single procedural block, my friend, you are living in a stone age of verification. So now we will understand this in more detail in our later video. But for being now, you can understand this theory well because see, OOPS is nothing but a theory part of thing. We will see more in detail. Like we will try to integrate much more example as we can. But first of all, you can go through this theory and then we will start the practical implementation. So that's the wrap up for today's session on OOPS in System Verilog. In the next video, we are diving into inheritance, polymorphism, and how to extend your test bench without rewriting a single line from the scratch. And if you found this video helpful, so go ahead and smash that like button, share it with your verification buddies, and subscribe for the next part of the series. Also, if you have any doubt or need this slide deck, just comment below or drop a mail shown on the screen. Okay, so let's meet on the next video. Okay, thank you.